Inside a completely sealed, dust-free laboratory in California, a team of senior hardware engineers gathered around an electron microscope. On the screen in front of them was a cross-section of a newly acquired silicon chip. Smaller than a fingernail, but dense enough to power advanced military equipment. They had spent 3 days meticulously shaving down the casing with lasers, layer by microscopic layer, expecting to find standard, commercially available architecture. Instead, what they saw shocked everyone in the room. The serial numbers etched deep within the silicon matched no known international registry, which meant, legally, this component was never supposed to exist at all. Even worse, the physical design relied on extreme ultraviolet lithography techniques that only one foreign firm on Earth had the license to produce. A firm that had been completely banned from selling hardware to this manufacturer 3 years prior. The room went dead silent, because if this chip was real, it meant someone had built an entire underground semiconductor supply chain, operating completely outside the reach of global law. And what they discovered inside the central processing unit was a hidden hardware backdoor that defied every rule of modern technology. To understand how this phantom silicon was created, we first have to follow the dark trail of smuggled industrial machinery across 3 continents and through international shell companies that don't exist on paper. It began with a quiet anomaly in international shipping manifests. For decades, the global chip-making industry relied on a fragile, highly centralized network if you wanted to build state-of-the-art microprocessors. You needed ultra-precise lenses from Germany, specialized chemicals from Japan, and multi-hundred-million-dollar lithography machines built in the Netherlands. If any single link in that chain broke, production ground to a total halt. So when foreign regulatory agencies imposed a total embargo, prohibiting the export of advanced manufacturing tools, Western policymakers were confident the threat was neutralized. Without foreign machinery, the target nation's tech sector would be frozen in time, stuck producing outdated, low-margin hardware forever. For the first 18 months, that strategy appeared to be working flawlessly. Factories stalled, new product lines were delayed, and stock prices tumbled as foreign suppliers pulled out their technicians overnight. Western capitals celebrated a decisive economic victory, believing the technological divide had been permanently secured. But behind the scenes, an entirely different operation was taking shape. While official corporate channels announced massive losses, a silent fleet of unregistered cargo ships began moving through secondary ports across East Asia and the Middle East. They weren't carrying finished consumer electronics. They were moving heavy, industrial machinery, decommissioned fabrication tools, spare optical parts, and second-hand precision equipment were quietly bought through complex chains of brokers. In some cases, entire manufacturing units were purchased under the guise of legacy repair facilities, only to be dismantled within 48 hours, repacked into unlabeled crates, and shipped across borders under false customs codes. When Western inspectors finally realized what was happening, thousands of tons of high-tech gear had already disappeared into a black hole. It was the largest industrial smuggling network in modern history, operating in broad daylight. Yet, having the physical tools was only half the battle. Without the proprietary software and precise chemical formulas, these machines were nothing more than multi-ton paperweights, and that is where the shadow engineers came in. Deep inside isolated industrial zones, thousands of top-tier scientists and software engineers were brought together under total secrecy. Many of them were veterans of foreign tech firms, recruited with blank checks and promises of unlimited research budgets. Their objective was clear: re-engineer every single software algorithm, chemical solvent, and optical system required to make the smuggled machinery function. They worked in grueling shifts, operating off-grid facilities that didn't appear on municipal power records, using specialized generators to avoid detection by orbital satellites. For months, experiment after experiment failed. Silicon wafers cracked under incorrect pressure levels, light wavelengths drifted out of alignment by nanometers, and billions of dollars in raw materials were reduced to toxic scrap. The economic toll was staggering. And inside the facilities, doubt began to creep in. Senior analysts warned that trying to reverse engineer 50 years of global innovation in a matter of months was suicide. Then came a catastrophic accident inside one of the primary research facilities. A critical optical lens shattered during high-voltage testing, completely destroying the only working prototype machine they had managed to construct. Replacement parts could not be smuggled in time, and the entire project was on the brink of total collapse, just when it seemed the embargo had finally succeeded. The engineering team made an unthinkable decision. If you're finding this deep dive into the hidden world of tech politics fascinating, consider subscribing to stay connected with stories shaping our global future, instead of trying to replicate the missing foreign lens. They decided to redesign the physics of the light source itself. They bypassed the conventional manufacturing method entirely, utilizing a multi-exposure technique that experts insisted was too unstable for commercial use. It required twice as much energy, generated extreme levels of heat, and required custom liquid cooling loops built directly into the silicon housing. It was inefficient, dangerous, and ridiculously expensive, but it worked. Against every known law of modern supply chain economics, they had produced a fully functional, advanced microprocessor inside a completely isolated environment. When news of this achievement reached foreign intelligence agencies, it was initially dismissed as state propaganda. The idea that a fully banned firm could produce top-tier silicon without foreign equipment was considered mathematically impossible. Until the microscopic teardown in California confirmed every worst-case scenario. The implications were catastrophic for Western monopolies. For 30 years, a handful of corporations held an absolute monopoly over global chip design and manufacturing. They set the prices, controlled the standards, and dictated which nations were allowed access to high-performance computing. That monopoly was built on the assumption that no single nation could ever replicate the entire global supply chain on its own. Now, that assumption had been shattered to pieces by forcing this challenger into absolute isolation. Foreign regulators had accidentally incentivized the creation of a completely independent, self-sustaining tech ecosystem. An ecosystem that didn't use Western patents, didn't pay licensing fees, and didn't respond to economic sanctions. And now, that independent ecosystem was preparing to scale mass production to levels the global market had never seen before. While Western firms struggled with rising material costs and complex international regulation, the newly self-reliant giant was pumping out millions of units at a fraction of the cost. They began flooding third-world markets with cheap, highly capable hardware, undercutting traditional suppliers almost overnight. Telecommunications providers across Latin America, South Asia, and Africa began quietly tearing out expensive Western gear and replacing it with the new, unsanctionable alternative. The market disruptive shock was immediate and brutal. Global suppliers saw their market share in key developing regions evaporate in a matter of quarters. Yet, the financial losses were only the beginning of the crisis. The real nightmare was hidden deep within the silicon itself. When the California lab analyzed the internal layout of the dissected chip, they noticed something far more concerning than smuggled technology, embedded in the hardwired logic gates, completely separate from the primary processing cores. Was a secondary circuit module. It had no documentation in any standard public database. It didn't respond to traditional diagnostic tools, and it appeared to operate completely independently of the device's main operating system. Further testing revealed that under specific, highly encrypted signal triggers, this secondary module could bypass every security layer installed on the device. It wasn't just a processing chip, it was a hardwired, hardware-level key, permanently baked into the physical silicon at the atomic level. Because the entire manufacturing process had taken place in total secrecy, there were zero external audits, zero international safety checks, and zero third-party verifications, and millions of these chips were already embedded inside critical infrastructure around the world: power grids, traffic management systems, financial data centers. And mobile networks were now running on hardware that no foreign authority could inspect or control. The Western security establishment realized they were completely blind. the very sanctions designed to protect global security, had created a massive, untraceable gray market that now powered the digital infrastructure of dozens of nations. And there was no patch, no software update, and no legal mandate that could undo it. Which leads us to the ultimate question shaping the modern world. We are no longer approaching a future split. The permanent supply shift has already taken place. The global technology market has officially divided into two distinct, mutually hostile domains. One domain relies on open market standards, international oversight, and complex global alliances. The other operates completely in the shadows, powered by sovereign supply chains, black market logistics, and hardware built under total state control, as artificial intelligence, autonomous systems, and advanced computing become the foundation of national survival. The competition between these two worlds will only escalate. Countries around the globe are now forced to make an impossible strategic choice. Do they rely on a Western system that can be locked down by political embargoes at any moment? Or do they integrate into an underground ecosystem that offers total political immunity? At the cost of total hardware vulnerability, the choice made by developing nations over the next few years will decide who rules the digital age. And as those shadow supply chains expand deeper into every level of consumer technology, the line between commercial hardware and state intelligence disappears completely. The old world of transparent, globalized technology is gone forever. In its place, a silent, invisible conflict is playing out inside billions of microscopic circuits, shaping the power dynamics of our planet, one chip at a time. And by the time the true extent of this transformation becomes visible to the public, the dark network will already be impossible to stop.